In this video, we're going to be exploring the slope of lines. These are all common phrases that we associate with slope. Slope is technically the rate of change or the steepness of our line. When we use formulas to calculate slope, we use the change in the y over the change in the x. And when we look at it on a picture, a lot of times we're going to talk about rise over run. But technically, slope is the rate of change or the steepness of your line. In example 1, we're given the picture of a line and we're asked to find its slope. So we want to know how steep is this line or what is its rate of change. Well, you'll notice they've given us two specific points to work with here. So we need to think about how do we get from this point to this point. To get from this point to this one, we would need to go down 2. That is the rise for this slope. If I'm going down 2 right here, that means we're going negative 2. And then we need to go over to get to this point. And we need to go over how many? Well, let's count them. So we're going to go over 1, 2, 3, 4, 5, 6. And we're doing that in the positive direction. So positive 6 is our run. So the slope of this line would be the rise, negative 2, over the run, which is 6. Now we always want to reduce these, so this would reduce to negative 1/3. So the slope of that line is negative 1/3. The abbreviation that we use for slope is the letter M. So you can write M instead of slope if you'd like. Now you'll notice it also goes through the y-axis right here. We could have used this point as well, or instead of the 2 that we chose. Let's try that and see if we get the same answer. So if I was going to use this point, we would go down 1, so negative 1, and over positive 3. And so the slope would still be negative 1/3. It doesn't matter where you start on this line and where you stop on this line. The slope is consistent throughout this line. You could actually even do it a different way. You could have chose to start at the bottom with this point and go up first. So if we're going to rise 2, that's a positive 2. But then to get to this point over here, we would have to go this way, which means we're going in a negative direction, or negative 6. So your rise would have been 2 and your run negative 6, which if you reduce that fraction, you're also going to get negative 1/3. The slope is the same no matter where you're at, as long as you use 2 points that are on that line. Let's take a look at 2 special cases. These are the 2 that give people trouble sometimes. Anytime you have a horizontal line, its slope or rate of change is 0. I always like to tell my students this. Let's think about skiing on the slope. If you're skiing on a slope that looks like this, if this is the mountain that you're on, and you just stand there and hope to go downhill, it's not going to happen because your speed will be 0. You're not going anywhere. Now let's look at this case. This is a vertical line. If you think about skiing on this slope, we're in trouble. This is not skiing. This is death. You do not want to go down this hill. That one has an undefined slope. We'll talk more about these later, but it's important to remember that anytime you have a line that's horizontal, it's going to have a slope of 0, and this is the death slope, meaning its slope is undefined. Sometimes we don't have the picture, and instead of taking the time to draw the picture, we just want some algebra to spit out the slope for us. If that's the case, this is the formula that you're going to use to calculate slope. Now, you don't need the formula if you want to graph it every time, but sometimes these numbers could be pretty nasty. I mean, you could imagine if we were talking about a cost analysis and some of your points were in the thousands, graphing that might be tricky. So this formula is going to be useful when we don't want to have to graph things, but we still want to know what the slope is. Now you'll notice in this formula, we see things like y with a little 2 after it. That's called a subscript, and it's referring to specific things in our points that are on the line. So if you had a point, we would label it x and y. And in order to calculate slope, you would have to have a second point so that we knew where we were going to and from, like we did on the picture. And the way we get these little subscripts is this is our first point, so it would be x sub 1 and y sub 1. And this is our second point, so it would be x sub 2 and y sub 2. And then you're going to just pull the values from these 2 points and put them into this formula to calculate slope. Let's give it a try. We're asked to calculate the slope between these 2 points. So again, we could graph these. They're not too big or nasty numbers, but let's go ahead and use the formula to practice that. This is going to be an x number. It's our first x number, so x sub 1. And this is a y value, so it is our first y value. We'll call him y sub 1. This is our second x number, so y sub 2, and our second y value, so y sub 2. And we are going to put that into our formula for slope, which is y sub 2 minus y sub 1 on top, and x sub 2 minus x sub 1 on the bottom. All right, let's plug it in. Y sub 2 is negative 5 minus y sub 1, which is negative 2. On the bottom, we have x sub 2, which is 6, minus x sub 1, so our first x value, which is 7. Let's simplify this following order of operations. Up top, we've got to put those together. Negative 5 minus negative 2. Well, 2 negatives right here are going to turn into a plus sign. If that's confusing, you can just type it in your calculator the way that it is. But either way, if you've done it correctly, you should be getting negative 3 for the number on the top. Then on the bottom, we have 6 minus 7, or negative 1. Now we always have to reduce and simplify these. First up, a negative over a negative is going to make it positive. So I know this is a positive slope. And 3 divided by 1, or 3 over 1, is really just 3. So the slope of the line that goes through those 2 points is positive 3.